We are cruising through our functions chapter, and I really like this chapter because I think it's a little more fun than just solving equations, and I think you guys like it a little bit more, which makes it fun for me. So we're going to take everything we've done so far. We're going to take inputs, outputs, domain, range, vertical line test, all of that, and we're going to make some functions into equations or make equations into functions. So remember, we have functions that can be represented by an equation, and we will also just call this, oops, don't want this, hold on, there we go. So our equation is just another way of saying it's our rule, or kind of the pattern we're going to follow by. And the equation will generate for us or make for us ordered pairs. And the way we do that is by taking an input. Remember, input is our x values. We'll take an input that results in a certain output. And we kind of touched on this the first day we were talking about functions in class and talking about independent and dependent variables. The graph of an equation is the set of all its ordered pairs, which is often, it forms either a line or a curve. Okay, so think of functions like a machine that takes whatever x value you want and produces a y value. Remember that x is called our independent variable, and what we're going to do is you always get to pick the x values. So if you remember in class when we talked about this, I made you all pick a number for x and we plugged it into equations and we got y's back. That's what we're doing with our functions. And our y value is our dependent variable because it depends on what we chose for x. So our first few examples here, we're going to use a table and graph it on our coordinate plane. So my first equation is y equals x plus 4. And we always follow that format of y equals because y depends on x. I have already chosen our x values, and what we're going to do for each of these is plug them in to our equation. So what I'm really doing is y equals, now instead of x, I'm going to say -5 from my table plus 4. And that gets me -1. So my y value for -5 is -1. And then I'm going to go down my table and continue the same thing. This time I'm going to plug in -4, and it's still plus 4 from the equation, which is 0. My third x value is -2, so y equals -2 plus 4. And that gets me +2. And my last one, 0, so y equals 0 plus 4. And the plus 4 is always coming from the equation that I'm starting with. It's the rule, it's the pattern. So 0 plus 4 gets me 4. And now I have 4 ordered pairs to plot on my graph. So I'm going to plot my 4 points. So I'm at -5, -1, -4, 0, -2, +2, and 0, 4. And we're going to go ahead and draw a line through our points, put arrows on the end, and we'll keep going. Okay, I know we love fractions, but I think these are going to cancel out pretty nicely. So for each of these x values, we're going to plug it into our equation for number 2. So we have y equals, and we're going to do 3/4 times -4 minus 2. Remember, your order of operations says to multiply first. So I'm going to do 3/4 times -4, which gets me -12/4. I bring down my -2. -12 divided by 4 gets me -3 minus 2. This comes out to -5. Okay. My next x value is 0. I'm going to plug it into the same equation. So 3/4 times 0 minus 2 gets me 0 minus 2, or -2. Okay. Y equals 3/4 times 4 minus 2. This will be 3 minus 2, or +1. And my last x value, 3/4 times 8 minus 2. So this comes out to 6 minus 2 equals 4. So the only thing that changed in all 4 of these equations I have written over here is what we plugged in for x. And those x values are just any numbers we want to pick. So I picked these 4. You could have picked 4 different ones. So if I plot these on my graph, going across to -4 and down to -5, staying at 0 down to -2, over to 4, up 1, and going across to 8 would be off our graph, but up to 4. All right, and again, I'm going to connect my points. I'm going to leave 3 and 4 open for you to do. Okay. This would have gotten you -6, -3, 0, 3. And our second one here, we'd have +5, 2, -1, and our last one would be -4. Okay, so make sure you've graphed your points. I'm going to be looking for those when we are in class together next time. Now, the big thing that comes with functions is what's called function notation. And function notation takes our equations that we're used to, these y equals equations, and instead of y equals, we write it as, we use the letter F usually, but we can use whatever letter we want. Then we put x in parentheses, and then we write out the rest of our equation. So the way we read this is we would say f of x equals, and then in this case, it would be 4x minus 1. The f of x, okay, this is just new notation. F of x is the same thing as y. So f of x is now the output, and x is the input. So the way we use this is we can always put into our function notation the values we want to use for x. So if you look at our first example, it says if f of x equals 4x minus 1, find f of, and now it's -7. And what this notation says is instead of x, we're going to plug in -7. So I'm going to say f of -7 equals, and I'm going to do 4 times -7 minus 1. It just tells you what your x value is that you're going to plug in. So we have -28 minus 1. This gets me -29. F of -7 equals -29. And what's really nice about this notation is this also tells us our ordered pair for our graph, because the number here, f of whatever, that's our x value, and our answer is our y. So this would be the ordered pair, -7, -29. So I'm going to do a couple more, and then the rest of these I'm going to leave open for you to try, and we'll check them in class. So I will do number 1 here, f of 5. So replace any x you see with the number 5. So now it's 5 plus 7. So f of 5 equals 12. And I'm going to keep going down the left side of my equation. H of x, remember I said you can use any letter you want. So this is 2/3 times 9. Sorry, I didn't replace my 9. Here we go. Okay. Minus 1. Again, all this says is anywhere there's an x, it gets replaced with the number we're choosing. So this is 6 minus 1, or 5. And the last one I'm actually going to do for you is over here in the bottom right corner, where I tell you f of x equals negative 3x minus 2. And we're going to do the opposite. We're going to find x when f of x equals 11. So now this whole thing, f of x equals negative 11, is going to replace the f of x in our equation. So I'm going to take negative 11, which is f of x, and replace it in my equation. So now I have negative 11 equals negative 3x minus 2. And what we have to do now is solve our equation for x. And this is just like how we've been solving equations all year long. So I'm going to add 2 to both sides, get negative 9 equals negative 3x, and then I'm going to divide by negative 3. So I got 3 equals x. Okay. So depending on what you're given, okay, the rest of these tell you your x value to plug in. But if they give you one like this, find x, you set it equal to that. So I know I've left a bunch of problems open for you to practice, and you also have the last page of the worksheet as homework. So try all of them, do your best. I do not want to see any blank worksheets tomorrow in class when I see you. You have to try something, okay? Rewatch the video if you need it. Reach out to me with questions if you have any. Use your textbook as a resource. And I will see you in class tomorrow with your completed notes and homework.